Hello, everyone, and welcome to our notes on 1.5 in Precalculus, Analyzing Graphs of Functions. In section 1.4, we studied functions from an algebraic point of view. In this section, we will study functions from a graphical perspective. We will study functions from a graphical perspective. Remember that for a set of points in a coordinate plane to be a function, it must pass the vertical line test. Make sure you spell the word vertical right. It's A-L, not L-E. It must pass the vertical line test. And what that means is that no vertical line intersects the graph at more than one point. So we'll just draw a couple graphs so that you can see what I mean. Let's say I had a downward parabola like that. You don't have to draw it exactly like mine, just any downward parabola. No matter where I draw a vertical line, I'm only going to hit one point. So a parabola is a function. It passes the vertical line test. Now I'm going to draw a square root function. A square root function would look something like this. It could be anywhere on the graph. I just chose to draw mine over there. No matter where I draw a vertical line, it passes the vertical line test. Sometimes you'll have a really crazy looking function. This is a W, which means it's something to the fourth power. But again, even though it's much crazier looking than the last one, no matter where I go, I still am only going to pass 1 point if I draw a vertical line. Something that would be an example of something that doesn't pass the vertical line test would be maybe something like a hyperbola, which is two parabolas that are sideways. Okay, a hyperbola would not pass the vertical line test. When I draw a vertical line, I would definitely hit 2 points. It's possible I could draw a vertical line and not hit any point. But to pass the vertical line, if anywhere on the graph you hit 2 points, then it doesn't pass it. So that concept, even though we did it in another section, is reiterated in this section. So make sure that you really understand it. And it'll come up all year. Every function has a domain. A domain is all the things that x can be. And a range. Range is all the things that y can be. If the function is already graphed, finding the domain and range can be as simple as looking at the graph. So when I look at this first graph, it's an absolute value graph, which are always a v. And I look at it and I see that it goes all the way. I couldn't figure out how to make this thing draw arrows, but it is supposed to have arrows. I'll go ahead and I'll put them on now. It goes all the way from the left all the way to the right. When it covers the whole entire x-axis, we say that the domain is all real numbers. There's a symbol for that, and it's a capital R with an extra line through it. Some books draw it real beautifully, all fancy and everything, but I'm not that good, so I just make it more like the paragraph symbol, but with the letter R. On this one, the domain does not go all the way from the left to the right. It doesn't even start until right here. That's that first point, which if you're looking, it's not 2, even though it's the second unit over. This is counting by 2, so this is 1, 2, 3. You always have to look at how the graph is being numbered. So this is the point 1, 4. But then it does continue. So the domain would be x is greater than 1. Is it equal to? It is. You may remember that if something is solid, then we can say that it's equal to, if it was an open circle, then it would be just greater than. Now the third one doesn't look like it goes all the way from the left to the right because it gets so steep, and that's why I chose it. Sometimes kids think the domain stops, but it does keep going further to the right as you go up and further to the left as you go down. So this domain is still going to be all real numbers, even though we don't actually see it hit all the way left and all the way right on our graph. So you do have to have a concept in your head about what a graph looks like. We are going to do range, but first I'd like to talk about interval notation. This might be new to most of you. Interval notation is where you write the beginning of the interval, comma, the end of the interval, and you either use brackets, which would indicate the same as a closed circle, or you can use parentheses, beginning, end, and this would be for use if you were trying to indicate an open circle. All right, I'm actually going to veer off the notes so that you can just stop and listen. Whenever you see a blank page like this means just stop, listen, don't try and write everything down, and I'll give you some examples. If I say x is greater than 3, you guys have been doing this since you were pretty young, where you would draw, you've got your number line, and when you get to 3, you would put an open circle, and then you would fill in that part. Or maybe some of you learned how to do it by saying 3, open circle, then actually going up and above it, which I really like. I didn't ever see a student do that until I was already a teacher. Interval notation is where we don't use this. Instead, we give it a start and an end. And since this one doesn't end, we just say to infinity. And I would use parentheses to indicate that I was going from 3 to infinity, but not including 3. If I were to fill it in, which old way would be x is greater than or equal to 3, new way would be bracket 3 to infinity. Some kids really don't like interval notation. It's hard for them to get used to something new. I personally love interval notation because I've got a beginning and an end. This one I always had to stop and think, which way am I going? Especially even if it was just that somebody wrote it backwards. Then I see the less than symbol, but I'm actually going in this direction, and it was a lot to think about. This one's always written where you start and where you end. Let's do another example. Like I said, you're not having to write these down yet. Let's say you were going from 2, 3, 4, 5, 6, 2 to 6. Since it's a closed circle at 2, you'd put a bracket. And since it's an open circle at 6, you'd put a parenthesis. I love it. Literally, it's so much easier than doing 2 is less than or equal to x is less than 6. At least I think so. Now, I will say that if you're going from a number, let's see, -1, 0, 1, 2, 3, 4. Let's say you're going from an open circle to another open circle. I guess I didn't actually fill this one in. Let's fill this one in. If you're going from an open circle to another open circle, this is where somebody made a bad decision. Then it does look like an ordered pair. This is not an ordered pair. And that is very unfortunate. If I had figured this system out, we would have had a workaround for this, because it does look like an ordered pair. Interval notation, this means you're going from -1 to 4, open circle. Let's just do one more. Let's say I'm going all the way from 5, closed, and it's this side. And if it goes on forever, then you would say negative infinity. Way out here is negative infinity to 5. And since it's a closed circle, it would be a bracket. Okay, so there was like a little mini lesson within the lesson. Let's go back now and see if we can write these domain and ranges in interval notation. In interval notation, all reals would actually be from negative infinity to infinity. Negative infinity to infinity. And this one would be where it starts and where it ends. So infinity is always going to have a parenthesis, or the other way. Okay, infinity is never going to be a bracket. Let's do range. Range is all the things that y can be. So on this one, I see that it's starting down here. The x number is negative 2, but the y value is negative 3. And then every other y value is higher than negative 3. So the range would be from negative 3 up to infinity. And since it actually can be negative 3, it gets a bracket. But infinity always gets a parenthesis. The range for the next one. This is the 0.14, but 4 is the highest it ever is. Every other y value is less than 4. So right here, I'm at 5, 2. See, that y value is less than 4. So you could say that all the y values are less than or equal to 4, but we want to try and use interval notation. So I'm going to say negative infinity to 4. Sometimes people write this one backwards. It is not 4 to negative infinity. That won't work. You have to pretend you're looking at it on a number line. And the last one. This range does go all the way from the bottom of the graph to the top, so it's all real numbers, which in interval notation would look like that, from negative infinity to infinity. So I realize that that's a totally new concept. Some people can't get interval notation quite that fast. We'll certainly keep working on it, but always feel free to come to office hours if you need a little bit more instruction on that. One little note that isn't in the notes necessarily, but it is on the homework, and I want to make sure you know how to do it, is they ask a really brief question where they say, what is f of 4? That means what is the y value when x is equal to 4? So on this one, you can't actually see the 4, but you might be able to extrapolate a little, like it's right there. It's really close. Okay? Can you tell that it goes 1, 2, 3, 4? So it's really close. It's right there. So at 4, the y value is 3. This is an ordered pair. So f of 4 is equal to 3. I didn't originally put it in the notes because I felt like everybody would know it, and then I thought, it's worth just reviewing for a minute. So on this one, if they ask you what is f of 2, then you would look at x is equal to 2, and you'd find the y value. This is always the x, and the answer is always the y. So f of 2 is 3. Okay, just giving you a little concept of it there. On this last one, if I said to you, what is f of negative 2, you'd go over to negative 2 and go down. A little hard to tell, but it looks like it's negative 4. So a little reminder on function notation. The average rate of change between any 2 points is the slope of the line through those 2 points. The line through the 2 points is called the secant line. And the slope of the secant line is denoted M with like a little subword, SEC for secant. So this is going to be really easy, and yet so many kids get it wrong because they just don't learn the new vocabulary. A lot of precalculus is algebra 2 all over again, harder, newer, taking it to a new level. So they're going to be calling slope average rate of change, but it's still just slope. But look how complicated they word it. If I just said to you, find the slope between 1, 2 and negative 5, 6, I bet everybody could get that. But instead, look at how they asked that example. So we're going to do this together. You know you need 2 points. So they give you the first x and they give you the second x, but they don't give you the y. But they give you the function. So you're expected to find the y yourself. So f of negative 2 is, make sure you got these parentheses in there, negative 2 cubed minus 3 times negative 2, which is negative 8 plus 6, which is negative 2. So negative 2 actually goes with negative 2. And then f of 0 is 0 cubed minus 3 times 0, and that is also itself. F of 0 is 0. Let's find this last one that they want. So now we know it's 0, 0, and 1 comma something. F of 1 is 1 cubed minus 3 times 1. So 1 minus 3 is negative 2. F of 1 is negative 2. Now at this point, you could just find the slope. If you have 2 points, you can find the slope. But you will find throughout the year that I'm a big fan of graphing things. So this graph goes as negative 2, negative 2, 0, 0, 1, negative 2. I know because it's cubic that it has that basic shape. And I'm going to do little bits on graphing all year long until you're really good at it. The best way to make a graph, I'm actually going to write this down. Best way to make a graph is to factor and find the x-intercepts. So if I factor this, it doesn't look like you can factor out or do any kind of normal factoring, but don't forget about factoring out. It's a great way to factor. X squared minus 3. And then I can find the x-intercepts by setting it equal to 0. Set equal to 0. So x is equal to 0. That's actually one of the intercepts. And then x squared minus 3 is equal to 0. I would have kept factoring that, but it's not factorable anymore. But it is solvable. So x squared is equal to 3. X is equal to plus or minus, don't forget your plus or minus, square root of 3. And the square root of 3 is about 1.7. So I know now that this crosses at 0 and at 1.7 and negative 1.7. Now I can make a good graph. I know it goes up. I'm not going to go too far because I got to get back down. It comes back down. It may actually bottom out there, but sometimes I try and show it not doing that just so I don't think that's definitely the bottom. It could be, but I don't want to assume that. I'm going to draw it like that. It's not perfect, but it gives me an idea. So the average value of a function is, they're saying from negative 2, right, to 0, 0, what is the average rate of change? which is a fancy way of saying what is the slope. So the slope, they're just looking for the average slope. So the slope is really steep right here. And then it's a little less steep. Less steep. Look, now the slope is 0. Now the slope is negative. If I actually averaged all those slopes together, this would be the average slope. So let's actually find that slope. y2 minus y1 over x2 minus x1. 2 over 2 is equal to 1. That is the slope of the green line. That is the average slope on the curve there. Then they wanted the average slope from 0, 0, this is for number 2, to 1, negative 2. Now, if you've graphed it, you can see that the slope is negative 2. But I have a feeling a lot of you are not going to graph it, so you do have to know how to do it by hand. The blue slope is y2 minus y1 over x2, over x2 minus x1. Negative 2 over 1, negative 2. So when they say find the average rate of change, when they say find the average rate of change, step 1, use the x values and the function to find the y values. That was the first thing that we did. Remember this, right? We found the y values. Step 2, write the ordered pairs. Write the ordered pairs. So that was the second thing we did, was we wrote them as ordered pairs so that then we could find the slope. I talked a lot more about it because I wanted you to understand the concept, but then I always like to represent it just in its simplest way, in case I lost you at any point with the overall concept. Do I want you to understand all the concepts? I do. But I also want you to be able to get through your homework and quizzes, and sometimes people aren't ready for the whole concept. They just want to know how to do the problem. So this is how you would do it. Use the x values in the function to find the y values, write them as ordered pairs, and then find the slope using the slope formula. But for the big picture people, what am I finding? The average rate of change. So this function has a negative slope, then a 0 slope, then a positive slope. Overall, can you see that it's more negative than that little bit of positive? What is the average if I were to actually find all the little tiny slopes? The average slope is negative 2. We do a lot with average rate of change in calculus. That's why they're kind of touching on it here. Let's put it into a real life word problem. The distance s in feet of a moving car from a stoplight is given by this function. S of t is equal to 20 t to the 3 halves. So you guys know that when a car moves away from a stoplight, the first few seconds, so in this case, first 4 seconds from 0 to 4, what is its average speed? Well, it starts off at 0, and it's going to have a speed at 4 seconds, but its average speed is going to be less than how fast it was going at 4 seconds. And then it has another average speed from 4 seconds to 9 seconds. As always, if you think you can do this on your own, you should pause the video, and I will write down the 2 answers in the margin. For those of you that are skipping ahead, if you get them right, then you should just skip this part of the video. Now for people that want it done. First step, use the function and the x value to find the point. 0, 0. 4, comma. So to get that, I'm going to plug this in. S of 4 is 20 times 4 to the 3 halves. You can put that into your calculator. Okay. If you don't want to put it in your calculator, I will show you how to do it while the rest of you are typing it in. Remember that the 2 on the bottom means square root. So this is the square root of 4, which is 2, and then 2 cubed is 8. So 160. But you're welcome to just put it in your calculator. So first step, find the y value. Second, write it as an ordered pair. And then third step, use the slope formula. 160 over 4 is 140. Don't forget your units. Feet per second. Maybe now if you didn't pause the video for the first one, you can pause it for the second one. S of 4, we already know, is 160. You get to reuse it. So my first point is going to be 4, 160, and then 9. So how do I find this? S of 9 is 29 to the 3 halves. Again, from Algebra 2, the half in the 3 halves means square root. So the square root of 9 is 3. 3 cubed is 27. So this is 20 times 27, which is 540. You can use your slope formula. 540 minus 160 over 9 minus 4. You can go ahead and do that math. And you should get 76 feet per second. If you're typing this into your calculator, then you can use the fraction button in order to make an actual fraction like that. Okay, so I want to just show you how to find the fraction button on your calculator. If you do alpha, this green button right there, which just turned red because I pushed it, F1, which is the y is equal to button, N over D means numerator over denominator. So I'm going to hit enter. Look, it makes a fraction for me. So then you can exactly type in what it is that you want. 540 minus 160. Now use the arrow key to go underneath over 9 minus 4. And you don't have to worry about getting the parentheses just right. You hit enter, and there's your answer, 76. So even in odd functions, even functions are symmetric with respect to the y-axis, while odd functions are symmetric with respect to the origin. You actually already learned this, so the good news is this is nothing new. We're just giving it a name. So an even function would be something that you could open or close like a book. It kind of folds over itself. That was not a great job. Let's do that just a little bit better. Something like that. Or if you had a circle like that, then it would be like that. Anything that is reflecting over the y-axis, that's considered even. Anything that reflects over the origin, like a propeller, see where it goes like that, that would be considered odd. So when we studied symmetry a couple sections ago, we just talked about symmetric over the x-axis, the y-axis, and the origin. So now we're giving names to 2 of them. So you can think about this for a second in your head. Why didn't symmetry over the x-axis get a name? They didn't give it a name. Because they're not functions. So these are even and odd functions. We actually really don't study symmetry over the x-axis because it doesn't pass the vertical line test. So instead, they focus just on even functions, which are the y-axis, and odd functions, which go over the origin. But as far as actually understanding symmetry, you've already learned it. This is just giving it a name. So a lot of times I graph things to figure out if it's odd or even. So when you want to make a graph, you're going to hear me say this all year. One of the best things to do is number 1, know the shape. So I already know that this looks like this. Number 2, find the zeros, which are also called the x-intercepts. They are the same thing. X-intercepts, zeros, same things. So you have this function. I'm going to set it equal to 0. That will tell me the x-intercept. Remember, the x-intercept is when the y is equal to 0. I do that by factoring. I factor out the x, which leaves me with x squared minus 1. I keep factoring, and I get x plus 1, x minus 1. And I find out that there are 3 different things that could make this 0. If x is 0, that'll make the whole entire equation 0. If x is negative 1, because negative 1 plus 1, that would make this 0, and then 0 times anything would make 0. Or if x was equal to 1. So there are 3 x-intercepts. And honestly, that is all you need to know. If you have these 3 intercepts and you know its basic shape, you've got yourself a graph. So it certainly looks like it's an odd function. If you were to spin it around, try and think if you were to take this corner and spin it 180 degrees, it would probably look the same. But if you can't look at a function and say, oh, I can tell that that's even or odd, the best way to know, so the graph is one way, the other best way to know is just to pick a point. So I'm going to say, what about when x is 2? So when x is 2, I get 2 cubed minus 2, which is 8 minus 2. Oops, I was so excited about my answer. Look, I already wrote it. 8 minus 2, which is equal to 6. So the point is 2, 6. I can't quite graph that, but it's somewhere up there. 2, 6. Now, if it's truly odd, then this is going to come out to be 2, negative 6. Because remember, odd functions means whatever's up there is now suddenly down there. Sorry, negative 2, negative 6. So if this is 2, 6, then negative 2, negative 6 should be on there. So if you want to confirm that it's odd, it's definitely not even. Even would have to be something symmetric around the y-axis. But it could be neither. So you can't just rule out, if it's even or odd, it could be neither. So I'm going to plug this number in. Now, sometimes people still get it wrong because they don't plug it in correctly. Don't forget, the negative 2 has to be in parentheses. Now, you could put that on your calculator, but I'm going to do it out. Negative 8 plus 2 is negative 6. So I did get 2, 6, and negative 2, negative 6. So the point would have been down there. So it is an odd function. X squared plus 1. So this is a parabola. Hopefully you're starting to recognize these. That's a parabolic function. Parabola. But not all parabolas are even. If the parabola is over here, that is not symmetric over the y-axis. If the parabola is there, it's not symmetric. You need something that is symmetric around the y-axis. And luckily, this is a parabola that is. It's just been moved up 1. And then from there, 2, 1, 2, 3, 4. So this is what it looks like. Remember that if it had been moved left or right, you would have seen it like this. I just made up the number 3. But this is the number that moves it left or right. So since this one was just an x squared, in other words, it's kind of like x minus 0 squared. That 0 means it didn't move left or right. This number on the outside is what moves it up or down. And so that's what you need to know. Again, though, let's say you're just looking at this going, but I'm so bad at graphing. I never really mastered graphing in Algebra 2. The other way to know if something is even is if the point is over here, then it's also over here. So let's make a little table. When x is 2, I get 5. So this is the point 2, 5. I don't even make the whole parabola. I just know that there's some 0.25 on this graph. Where did I get that from? 2 squared plus 1. Now I'm going to do a negative 2. And if I get 5 again, not negative 5 this time, to be even, I want it to be 5, then I know I did good. Now, of course, if you don't use your parentheses, somebody's going to type that into their calculator, and they're going to get negative 3. And they're going to say, oh, not even. But you have to put parentheses because the whole thing is being squared. So it's not negative 3. I'm just going to erase it so nobody sees it. So 4 plus 1 is 5. So it is even. So even if you're not good at graphing, you can always make a table. Even ones will be an x and then a y, and then the opposite of x and the same y. Odd functions will be an xy and then a negative x, negative y. Your book says that with this little thing right here, which I'm putting in the box for you. But I think that the example is just easier to work through than reading that box. But that's my job, is to try and make things that sound complicated by giving you examples, making them easy for you. Of course, number 3, if you're given a graph, you can just look at it. If it's symmetric around the y, then it's even. If it's symmetric around the origin, and if you're not sure, pick a point. I see 2 4s on there. Do I see negative 2, negative 4? I do. So this one is odd. This one has the point 2, 1, but it doesn't have the point negative 2, negative 1. So it's definitely not odd. And of course, you can tell right away that it is not symmetric around the y-axis. So this one would be neither. Oh, I skipped that little piece right there. In addition to the domain and range of a function, so we already did domain and range, we have left to talk about the zeros, maximum, minimum, and increasing, decreasing, and constant. So chapter 1, I was going to say chapter 1, all the chapters are a struggle for kids because in pre-calculus, it's like you're learning a bunch of tiny topics, but they're all topics that you did in Algebra 2. We're just trying to get better at them. So it feels like a million things. I'm sorry, it is a million things. Bunch of little things to know. So the zeros of a function are the x values for which f of x is equal to 0. In other words, it's the x-intercepts. The zeros and the x-intercepts, same thing. Okay, x-intercepts, zeros. Same thing. So in other words, you're saying what x would make this equal to 0? What x would make this equal to 0? So we've already done this just a couple sections ago, but these 4 examples are here for a purpose. The purpose is that most of the time, I'd like you to try and factor. That's going to work most of the time. But these 4 examples are going to show you the times when that doesn't necessarily work. But we're going to try and factor it. Let's see if it's factorable. Remember that the first times the first makes the first. So this has to be 3x and x. There's no other way to factor the 3. And then the last times the last makes the last. Now that does have choices. 1 and 10, 2 and 5. So the question is there any way to make that work? You'll have to get better at it. There's a little bit of playing around in it, but 5 and 2 is going to work. Then the last thing is you have to get this middle term, and that comes from the inners and the outers. So if you made this a positive 6x and a minus 5x, you would get a 1x in the middle. So to make that a negative 5x, this needs a minus, and this needs a plus. And then I go back and I check my green. The negative 5 and the positive 2 does make negative 10. So factoring is going to be the main way that you're going to do things. All right, I'm going to finish this one up here. So 0 is equal to 3x minus 5 times x plus 2. So when you have two factors that make 0, one of the two factors is actually equal to 0. So you can set them both equal to 0, and then you can solve them. X is equal to 5/3, and x is equal to negative 2. So when you're listing zeros, you can just list them. The zeros are negative 2 and 5/3. If I ask you to state it as an intercept, you would actually write it as an ordered pair. But they mean the same thing. I'll actually take it either way. So number 2 is still factoring, but the point for number 2 was to remind you about factoring out. A lot of people forget that you don't always jump into the two parentheses. Factor out first. So if I take out the x squared, I'm left with 9x squared minus 25. That's called factoring out. And that gives me 3x plus 5, 3x minus 5. Two terms is easy to factor because they have to be the same in order for the inners and the outers to cancel, which means either my three equations are either 0 is equal to x squared, or 0 is equal to 3x plus 5, or 0 is equal to 3x minus 5. X is equal to negative 5/3, and x is equal to 5/3. Skipped a couple steps on that last one, but you are in precalculus. I'd like to think you could subtract 5 and divide by 3. So those are my 3 zeros. Now, even though factoring will probably be 90% of what we do, there's definitely going to be times when it's not. So a little review from algebra here is when you set something equal to 0, and you can't factor it, but it has a square root, you can square both sides. Luckily, when you square 0, it's still 0. So I actually just get this. So I do see an x squared, which normally I would try and factor. But if there's no x term, so like there's no term that is just something x, if there's no x term, you can take a shortcut. You can just solve it. So right now it looks like this. I'm going to add x squared to both sides, and I get x squared is equal to 10. So x is equal to plus or minus the square root of 10. Don't forget that plus or minus. Those are the zeros. So a little review from algebra. When you have a square root in an equation, you can square both sides to get rid of it. Okay, last one, finding zeros. So remember, to find a 0 means to set it equal to 0. So I set it equal to 0. And then this one is about clearing fractions. Clearing fractions means the problem looks hard and scary because it has a fraction in it. I can get rid of that fraction by multiplying both sides. As long as you do it to both sides, it's always okay. By t plus 5. On this side, to multiply by t plus 5 and to divide by t plus 5 undoes it. So it's gone. And on this side, 0 times anything is still 0. And now it just became a really easy equation to solve. T is equal to 3/2. As a 0, you can state it like that. If I asked for an x-intercept, you'd put it as an ordered pair. But these directions just said find the zeros. So you can leave it as t is equal to 3/2. Okay. Let's go on to the next page. 2 more here. Oh, no, we already did that one. It's just repeated. Okay, so remember what I said. Factoring should be your first method, okay? Again, 4 terms seems so scary to people, but I actually love it when there's 4 terms. I think it's easier because you don't have to make the inners and the outers add up to something. They're already separated. So I think to myself, the first times the first makes the first. So x squared times x makes x cubed. The last times the last makes the last. So in those green spots, I could put 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. I've got choices. But what's beautiful is that normally you'd have to play around with it and see how to make your inners and your outers add up to some kind of middle term. But you know you want negative 4x squared. So to get negative 4x squared across from the x squared must be a negative 4. So I'm going to end up using this one, which means if it's a negative 4, it's going to have to be a negative 9 to make a positive 36. So this is a negative 9, and sure enough, inners and outers, that gave me negative 9x. This one can be factored further. X plus 3, x minus 3. I'm going to rewrite the x minus 4. You always want each step to be consistent. Now, some people wouldn't show this step, and that's okay. But since this is the instructional video, I always want to make sure everybody really knows what I'm doing. I'm saying that if you have two things being multiplied together, let's say 24 times something, and you get 0 for an answer, you know that that something is 0. There's no question mark there. It's definitely 0. But what we're doing is we're saying something times something is 0. Well, now you don't know which one, but one of them has to be 0. So now we have 3 things being multiplied together, and 0 is the answer. I got news for you. One of them is 0. What would make this one 0? If x was negative 3. What would make this one 0? If x was 3. What would make this one 0? If x was 4. So the zeros are negative 3, 3, and 4. Those are the zeros. Okay. What do we got next? So to determine if a function is increasing, decreasing, or constant, look at how the graph moves from left to right, just like you read a book, left to right. In basic concept, this is super easy. I'm going to get my highlighter here. Right here, definitely decreasing. Nobody ever gets this wrong. Where is it decreasing? Decreasing, decreasing, decreasing. Oh, stop. Where's this one decreasing? Right there. Oh, and actually it's still going down. It changed its shape. It's still going down. Where is it increasing? Definitely increasing. Definitely increasing. Definitely increasing. Where is it constant? Only in one of them. This one right here, it has a little constant section. This is not my worry. I am not worried that you can't look at a graph and tell me if it's increasing or decreasing. My question is, can you write it? Can you tell me in interval notation whether it's increasing or decreasing? So what I like to do is mark this spot with a -2 and mark the ends of the graph with infinity. Now you can say, using interval notation, from -infinity to -2, it's decreasing. That's what makes interval notation so nice. And then from -2 to infinity, it's increasing. This one's also -2. This graph looks completely different. And yet, oops, I don't know what that happened. And yet, it has the exact same answer. From -infinity to -2, So you're giving me the interval on which it's happening. It's decreasing. They're always talking about the x when they're talking about increasing or decreasing. So through this whole stretch from negative infinity to negative 2, that's the break point. But once x is negative 2, the graph starts to increase, and it does that all the way until it reaches infinity. This one I'm going to mark with negative infinity, negative 2, and now I'm also going to add a positive 2 before I get to infinity. So what is the graph doing from the negative infinity to the negative 2? It's constant. So this is interval notation. I'm giving you the interval where it's constant. From negative 2 to 2, the graph is falling. It falls on a line, and then it falls on a little curve, but the whole time it's falling. So we call that decreasing. And then this last interval from 2 to infinity, this is just marking the interval, it's increasing. So you have to express your answers in interval notation. The relative minimum or relative maximum of a function are most easily determined using calculus. However, we can determine these points graphically by studying where a function changes its increasing, decreasing, or constant behavior. Try this for the graphs above. So we're actually going to go back. So we call this point a minimum. This point is a minimum. This point is not a maximum or a minimum because it's maximum throughout this entire section. But this point down here is definitely a minimum. Now, of course, these graphs were drawn for you. What are we going to do if we don't know how to find the max or the min? Well, you might be able to look at this one and say, oh, it's a parabola. So if I can find the vertex, I can find the max or the min, which is great. But I'm actually going to teach you how to do these last two on the graphing calculator. So we'll plug them in and we'll use that feature. So I know that the graphing calculator is new to a lot of you in this class, so I'm going to go slow and show you the features. If you've had me before and you're comfortable with your calculator, you might even remember how to find a max or a min. But for those of you that are new, the way we make a graph is to go up here to this y is equal to. After I push it, it's going to turn red. It might help you follow some of our steps here. So y is equal to, and then you're going to type the function in, 3. For the x, you're going to use this x next to the green button, x. And to make the square, I'm going down here. I can just hit it, and it'll make the square for you. Minus 2x minus 5. Now I'm going to go to this graph button. Woohoo! Made the graph for me. So I can see that it doesn't have a maximum. It has a minimum. I'm going to show you how to find that. First, go to second, and then trace. You want to find the minimum, number 3. Now, some graphs have more than one minimum. So in order for your calculator to say, where are you looking? Tell me what you're looking at. You have to give it a left bound and a right bound. So I look at that minimum, and I'm going to take my cursor and make sure I'm definitely to the left of it, and then hit enter. And now it's saying, what's the right bound? I'm going to arrow over until I'm definitely to the right of it, and I'm going to hit enter. Okay, now this is a funny thing that I can't explain until calculus. It's a little confusing, but it's going to ask you for a guess. It doesn't matter to me what you guess. I never guess. I just hit enter. And there you go. It found the minimum for you. The minimum is that x is equal to a third. 0.3 repeating is the same as a third. And y is equal to negative 5 and a third. It's that simple to find it. Let's do one more. Y is equal to, so I'm going to use this clear button. And I'm going to type the next one in. Now, x cubed doesn't have its own button, so I'm going to use this caret key, x cubed. You do have to remember to arrow off of it. You're still in an exponent until you do that. Minus 3x, but for squared, I use this one next to this, near the 7. instead of using the caret key. Saves me a stroke. +1. I hit graph. So another window that's really nice, this is your standard window, is if you hit zoom 4, it kind of opens it up a little bit, but it didn't, it made it a little too low. All right, so I'm going to go back to the standard window, which is zoom 6. I was hoping that it wouldn't be quite so tight in there. So I'm gonna find the max and the min. So again, the steps are second, trace. And I'm gonna do the minimum first just because it comes first in the list. So look where it's starting, way up there. It's definitely not there. So I'm looking at this and I'm thinking the minimum looks like it's somewhere around x is equal to 2. You don't actually have to scroll over. I actually never scroll over. Instead, I say, well, it looks like the minimum is when x is equal to 2. So I'm going to say it's between 0. I just hit the 0 button. And I hit enter. And say 4. Enter. See how it made 2 lines? It's saying find me the minimum value in that interval. So all you're doing is giving it a range. You don't need to guess. And it found it. Make sure you write that as an ordered pair on your paper. To find the maximum, second, trace, and now you're going to do number 4. So again, it's leaving the cursor over there. That is definitely not what you want for your left bound. It looks like the maximum is close to 0. It's clearly not 0. It's a little bit to the left of it. But it's definitely bigger than -1. So I'm going to say negative. Make sure you use the negative key and not the subtract key. -1. Enter. See how it made a line? And it definitely happens before x is equal to 1. So I'll say 1 for my right bound. And it's saying, okay, this is the range I'm going to look in. Between -1 and 1, I'm going to look here. Would you like to make a guess? No, I never guess. Enter. And look, oh, see, it was just a little less than 0, right? So that's what they say the maximum is. And that's how you find the maximum and minimum on your calculator.